Welcome to the video on how to shuffle cards, a deck of cards. It's basically a video discussing how to manipulate arrays, chapter 7 in the book and in the online course. And so let's take a look at this. This is I think it's a program in the textbook, but it's your standard classic program that you should really deal with and understand. In particular, many people like to create a main method and they put a ton of code inside the main method. Now that code, the main method should just be a driver of your logic. The main method should have very minimal number of methods or lines in it. And so basically the main method will create some data and pass that data around to different methods. Those other methods will manipulate that data and will pass information back to and change that. It'll basically change that data, pass that changed data back to the main method, and then the main method takes that data and passes it to other methods. Now, like for instance, line 48 here. This is a very short and sweet main method, 4 lines. Okay, so the main method will create a deck of cards. Much like when you go to CVS and you buy a deck of cards, those cards are in order. There's a zeroed card, a first card, a second card. This is what comes back from this deck. So while we picture this deck, which is an array of integers, okay, each integer represents a particular card. So if there's 52 cards, it'll be an array from 0 to 51, and what's inside that array are indexes to a particular card, numbers that represent the particular card. So picture this as just a deck that you get from CVS, all nice and shiny and all in order. We're going to take that deck and shuffle the cards. Now what's going to happen here in line 47 is we're passing the array to that shuffle cards method. Because you're passing an array is an object, and an object is passed by the way you represent an object is through a reference, basically a pointer to that data. And when you pass a pointer to the data, this method is free to manipulate that data, change it around, and the main program will see the change. All right. So picture line 47 to be an array. You know what comes back is a shuffled deck of cards. All right, and then what we're going to do is take 5 cards to represent a particular hand, and we're going to take those cards from that deck, the first 5 cards, and what comes back is a hand that represents the first 5 cards, and basically it's an array of 5 integers that I'm going to display here. See, I could take this code and understand what it does because the methods use good names that describe what they do, and I could tell what's happening here. I create a deck, I shuffle it, I deal 5 cards, and I display those 5 cards. Okay, so let's take it one by one. A knit card deck. Come back up here. Well, a knit card deck doesn't take any particular parameters. It returns an array of integers. So inside, we're going to have to create that deck right there, line 5. We're going to create that deck of 52 cards, 52 integers. Remember, each integer represents a card. And what we're going to do is just initialize every element in sequential order, 0, 1, 2. So basically, deck of 0 gets the index 0, deck of 1 gets the value of 1, deck of 2 gets the value of 2, all the way up to 51. Deck of 51 is equal to 51. So each element inside that deck is a sequential number that we're going to return back to the main program. Okay, so that's what we have here. Basically, what we have is 0, 1, 2, comma, comma, 51. That's what comes back from that array. Now, we're going to take that deck and pass that array. This is an array of values. When you pass an array, you're passing a reference, like a pointer to that array. we're going to pass it to the shuffle cards method. Deck is an array of cards. And so what happens now is if I were to do something like this, deck of 5 equals 313, okay? Let's do that. Let's run that. Deck of 5 equals 313. You're not getting a copy of that array. You're actually manipulating the original array. So if I come over here, and let's just pretend, let's print that out. System.out, let's print out deck of 5. Okay, so we got that. Hopefully we'll see 313 come back. Oh, I didn't shuffle it. I put this in the wrong spot right there. Now we'll see deck of 5. See, I have to call the method so that before we can see the 313. And deck of 5. Oh, I'm losing my mind. I'm losing my mind because here's the deal. I need to see what happens is I made this assignment, but then I randomized the data again. So with the code here. So why don't we do this? Why don't we comment this out? Comment all this code here. Okay, that should be good. Now, I'm going to retire right now if I don't get back 313. There you go. There's a 313. Okay. Now, this is certainly a silly statement to make, so let's just get rid of that. Also, while we're here, integer Tony. I'm going to have another parameter, Tony. I'm going to set Tony to be equal to 567. Okay, I make that assignment. Let's make Tony. Let's have a variable here. Integer T equals 455. Okay, and I'm going to pass T into that shuffle decks method. Okay, let me print out T. Yeah, let me print out T. Okay. So what happens is I pass 455 to the method. 455 goes in. Tony becomes 455, comes in as 455. Tony gets assigned 567. What comes back out of here? Okay, I'll let you think about it. 1, 2, 3. If you said what comes out of here is 455, you'd be absolutely right. Not 567. There it is. This illustrates something. This illustrates that simple data types, not arrays. Arrays are objects. Objects are represented by pointers to the object. You don't need a pointer to represent a simple data type like an integer. You pass 455 as that second parameter. Tony here becomes 455 locally. If I make an assignment to Tony, it's only an assignment to the local variable of that method, and so only 567 gets assigned to the local variable. It does not touch the main method here. So that's pass by value, and you need to understand that mechanism. Let's get rid of this. Let's go back to the original program right here, and let's get rid of Tony. A lot of people would like to see that happen. Let's go over here, and I think we're good to go. If we go ahead and run this program, yep. Let's see. Oh, I got to bring back the code. Okay, run it again, and hopefully we'll see some random. Yeah, King of Spades, Ace of Spades. Okay, good. All right, let's go back to shuffling the cards. I come in with a nice initialized deck, and here's what I'm going to do. Here's how you shuffle. I'm going to basically visit. I visits every element of the deck. 0, 1, 2. This first line represents the integers. These are the values inside the array. Obviously, I'm not going to go up to 51. I'm going to take the first 7 elements here for example. So I points to 0 to this value right here. What I do is I generate a random number that's a number between 0 and, in this case, 6 in my example. Let's pretend this is what this does. We've seen this before. Take math.random times the length of the deck, convert it to an integer, and that's a 0 to, if the deck was 7 cards, that would be a number between 0 and 6. So let's pretend I have my random number to be 4, the fourth. That's the point. That's the index, not the value, 4. What I'm going to do is swap the 0th element and the 4th element so that this is what happens. 4 and 0 after the first iteration. And this code right here swaps values. And notice any assignment to the array gets seen by the main program. Good. So now I is 1. Points to this element. Let's take a random number. I'm making this up now. Let's take the number 5, index 5. I'm going to swap the 5th element and the 1st element. 5th element and the 1st element. Let's go make it 1. And see, it's already starting to look sorted or shuffled in random order here. And you keep doing this for every element all the way to the end, you're good to go. Okay, you've got yourself a nice shuffled array. Now that's good, that's great. We got a shuffled array, and then what we're going to do next is deal out 5 cards. Here's how we deal out 5 cards. You pass it the deck. Now I'm very careful not to change. There's no reason for me to change the deck in this deal of cards. I certainly am allowed to go ahead and do this silliness. Okay, there's nothing that prevents me from doing that, but I have to ask the question why. The main program is going to see that 313 in the 3rd element of the deck. Just be careful. Don't do that. Deal of cards should not change the deck. I have to pass it the number of cards I would like to that I return, and I have to create a different array, another array. I'll call that array hand. Give me an array of, I guess count as 5. Give me an array of 5 elements, and what I'm going to do is I'm going to start at the top of the top of the deck. The 0th card gets assigned to the 0th hand. 1st card to the 1st element. 2nd card to the 2nd card of the hand. Then return the hand. So we're going to get the first 5 random numbers back, and it's not enough to, let's just display. Let's do this. Let me show you what comes back. Pretend we don't have this method, display hand. Let me say this, sysout, and I'm going to print out arrays dot toString, come on, toString hand. That's a nice little method that I can go ahead and use. Quick fix, import it. Okay. Now let's see what comes back out of this. Yeah, okay. I get 5 random numbers. 5 random numbers, yeah, 5 random numbers, but that's not good because I don't know what the 15th card is, the 22nd card is. I do know that they represent individual cards, so why don't we do this? Let's write another method, display hand, pass it to hand, pass it to 5 cards, come up here, let's make it bigger, and what I'm going to do inside that display hand is define my suits, because since I'm displaying my hand, I would like to say 2 of spades, 3 of clubs, that kind of stuff. Suits is an array of 4 standard suits right there. That's basically the way you initialize. When you have an initialization, when you define your variable, you can initialize it to those strings right there, and that's what we have, an array of strings. And I added final there to prevent me from doing something silly like suits is equal to new string array of 50 or something. I'm not sure why I would do that, but it prevents me from doing that because it's a final variable. So things that tend to be constant, define final, because certainly the suits and the ranks, ace, 2, 3, 4, etc., those are constants. So define them as that. What I would like to do is go through my hands, look at my 0th card, the 2nd card, all the way up to the 5th card. Okay, the length of the hand, I don't have to pass it to count because the array itself inherently knows how big its hand is by the length parameter. I grab the suit, I grab the rank by doing this. This guy right there, when you divide the hand by 13, it's got to be a number between 0, 1, 2, 3, not 4, but because 52 divided by 13 is 4, but the biggest index you can possibly have is 51. So, integer division. 51 divided by 3 is 3 point something, but that point something is ignored because this is an integer. Okay, so 0, 1, 2, or 3. Use that as an index to specify which suit you have. Now, if I do a mod 13, the idea is you have the remainder. After I divide, okay, I'm going to say the first 13 cards are spades, the second 13 cards are hearts, etc. What I'm going to do is after I divide, I do the mod. This is going to be a number between 0 and 2. If you divide by 13, the remainder has to be a number between 0 and 12. Use that as an index to get the rank of the card. So the 0, if it's 0, you get the ace. If it's 1, you get the 2, etc. I grab those into individual suits, strings, and I print them out, and you saw the result by just looking at the result right here, and it works great. There you go. So, what else can I say about this? What I could say is this is not the template. If you were going to submit this code, you need to put this inside the template. All right? Because I just didn't want to deal with the template right now because the idea is to focus in on the arrays. But if you're going to submit this, you need to use the course template, which has the global header, you know, the ability to keep running over and over again until you decide you want to quit. Private methods. Okay, the world doesn't need to see the way you do things. The only thing that needs to be public in order for you to run it is the main method. And I think we're good to go. So I think we'll finish the video right here. All right. We'll see you in the next video. Take care.